provider network, we have two types of router, PE and P. What is the full form of PE router? PE.
Provider edge router.
And this P router?
Provider router.
Provider router.
Within the service provider.
In the customer network, you can see we have CE router. CE stand for
Customer edge.
Customer edge.
Right. So let's suppose this is a bank. Bank has multiple sites, right? Just I have taken example of two sites, side 1 and side 2. It can be a corporate, bank, hospital, university, and both the sites are at different location. One is in Mumbai, one is in, let's say, Delhi. Both the sites are connected through service provider network. This service provider can be Tata Communication, can be Airtel, can be Jio, can be BT, can be NTT, any service provider. So service provider engineers are going to configure these routers, P router and P router. Actually, P router is already configured, right? P router is also already configured. Any IGP protocol is running OSPF or ISIS. Most of the time, you will encounter either OSPF or ISIS for internal reachability, like for loopbacks 1.1.1 and 3.3.3. Between all P to P, reachability will be there with the help of loopback. And between P1 and P2, you will have lots of path. Right now we have single path via router number 2. But in production, you will have lots of routers, lots of path. And like these two PE, you will have multiple PE routers as well. So all the PE routers are reachable with each other. And now imagine you are a network engineer working in service provider network. You are working in service provider company. Let's say you are working in Tata Communication, and I am a network engineer who is working in the bank, right? I am enterprise network engineer who is working in this bank. So I will manage this router. I will manage my LAN switch and whatever end devices we have here, users, servers, will us configure the client machines, like will provide IP address gateway through DHCP. Here we'll configure the relay agent. After that, we'll enable the BGP. But how I will get to know about the ES number of service provider, what ES number service provider is using, or how service provider is going to give you the connectivity, like how service provider engineers will give connectivity to customer. So you will have mutual communication, you know, like if you are the network engineer in the customer side, then you will have communication. You will talk to service provider engineer that, bro, we have activity tonight. We are going to connect this customer side to service provider network, then this customer side to this router, and after that we will verify the reachability. Then later we will apply QS and all other things as well, policies, who are allowed to access what traffic you want to prioritize, those all. The very first thing is connectivity, right? Service provider will be sitting somewhere in the NOC, right? From there they will have access to both the P router through management network. Similarly, you will be sitting somewhere in the NOC, through management network you will have access to both the routers, right? Or maybe you will send field engineer over here who will connect LAN cable, WAN port, and after that you will take access to FE's laptop, and you are going to configure BGP by talking to service provider engineer. So this is a real-time scenario where I am just connecting two sites through a service provider network. In the service provider network, we have even simple connectivity. This is a cloud service provider, what we call it MPLS cloud, because all these provider routers will be forwarding traffic based on label, right? These providers can note, install customer prefixes in routing table, because same service provider is connecting more than hundreds of customer like you. And right now we have only one submit over here. Might be possible that in branch 1 we have 100 prefixes, in branch 2 we have again 100 prefixes, and like this, if this company has 100 sites around the globe, now you can imagine number of prefixes in one enterprise. And like this, if this service provider is connecting 100 customer, then you can imagine 100 multiplied by 100, and after that whatever value you will get over here, multiply by again 100. So 1 2 3 4 5 6. So this is total number of prefixes, right? We cannot import inject these routes inside the routing table of provider routers, because here we have only one provider router. Imagine now we have 100 provider routers. What if all the routers has a route in routing table? Will it cause issue? No, it will cause only one issue, maybe CPU uses, hardware uses, right? So what we can do, we can purchase the expensive router over here, XR router, right, with high CPU, high memory. Then problem solved? No, problem not solved. How router forward traffic based on destination IP address. So all the routers are going to compare 32 bits address with their routing table. It will find the exit interface and then forward. Let's suppose one router is taking 0.5 second to process one packet. This is processing delay. On the device we have processing delay, interface delay, guys, okay, then link delay, whatever. Right now I'm just talking about processing delay. We have 100 routers and on one router processing delay is 0.5 second. So we have 50-second processing delay. When user sitting over here are going to talk to any user sitting over here over call, then processing delay is more than 50 second. So no one can talk over call over here, right? Voice is delay sensitive traffic. User who is accessing application will not work properly. So we have lots of issues if we are going to import customer prefixes inside the MPLS cloud. We'll never do that. Like this provider edge router and this provider edge router is connecting this customer. It will have, this provider edge router will have route in routing table. It will directly advertise to this router, directly advertise to another side of PE router. Similarly, if same service provider has, let's say, connectivity of another customer B, right, a hospital, side 1, and another side is over here, connected like this. This is another PE3 router. So this is customer B, side 2. So customer B side 1 is advertising some route 2, again this P router, and this time this P router is going to directly advertise to this P router. So you will have one BGP session over here, one BGP session over here between all the P routers, and all the provider routers inside the MPLS cloud will be forwarding traffic based on MPLS label. And you will understand how MPLS label based forwarding happens. But before that, let me show you the connectivity, how you are going to make connectivity between these two sites. Is topology clear to everyone? Any question? What is PE router, what is CE router, what is P router?
Yes. Sir, that connection between CE and PE, would that be like physical link?
Yes, this is fiber link.
Okay, thanks.
This is fiber link, and here it is not sure that every time you will use BGP only. Here you can have OSPF routing protocol also, right? In that case, what provider will do? Service provider is going to redistribute OSPF into BGP, and then it will advertise to this router. Again, here you are learning, let's say, EIGRP protocol. So this provider edge router will redistribute BGP into EIGRP, and this way you will send route of side 1 to side 2. Right, this is also one scenario we will discuss after the BGP. Right now I'm using BGP between service provider and the customer router, as well as between PE to PE. PE to PE, every time you will be using BGP only, because can I use OSPF between 1.1.1 and 3.3.3? Is it possible? Or ISIS? Or EIGRP? No. Right? This routing protocol works with connected devices only, and 1.1.1 and 3.3.3 are not connected, correct? So here we don't have other option. We have only one protocol, that is BGP. Clear?
Yes, sir, in real time, there are customer edge and PH router. There are in between switches, na?
Here, yeah, definitely. You will have many devices, right? MUX, L2 devices, L1 equipments, lots of devices will be there between C and P.
Okay.
Done. So in this scenario, IP address is already configured. Let me access R1 first. Let me access all the routers. Let me verify the basic connectivity, right? Like the OSPF configurations, IP configurations, which you all knows. See on router number 1, if I will show you R1 configuration, interface, so IP interface brief exclude unassign. Here you can see my IP configuration on F 0/1 G 0/1 G 0/0. 0/0 is customer facing interface. 0/1 is provider facing interface. Like this interface is going towards MPLS cloud, and this interface is going towards customer network. Then we have one loopback for BGP, and then so IP protocol summary. So IP protocol summary. So I'm running OSPF 1. So IP OSPF neighbor. You can see my OSPF neighborship is already up. So IP route OSPF. So you can see 3.3.3 is present in my routing table through OSPF routing protocol. If I am going to ping 3.3.3 with source 1.1.1, you can see ping is working. This is the very first thing which you need to ensure inside the MPLS cloud. Now doesn't matter how many paths, how many routers are there between these two PE. Doesn't matter. We have created one loopback on PE1, one loopback on PE2, and both the loopbacks are reachable through any IGP protocol or through a static routing. Doesn't matter, because see, in production you will have multiple paths. Definitely you will not go with a static route. Most of the time you will discover, you will encounter OSPF or IS. I will talk about ISIS also later, right? You will understand the benefit of using ISIS over OSPF. ISIS works at layer 2, so it uses less CPU as compared to OSPF. Apart from this, on provider router, just I'm running OSPF, and I'm going to enable MPLS on both the interfaces, interface range G0/0 and G0/1 MPLS IP. And save it, and I'm going to close the console of R2 because I'm not going to configure anything else on
Sir, if
R2.
you have OSPF there, do we need MPLS also?
Yeah, definitely.
Why?
Because it is not going to install customer route now, bro. Watch yesterday recording.
Oh, okay. Okay.
Okay, so this is interfaces. Just I perform interface. I have configured the IP addresses on interfaces, and I have enabled so MPLS interface. I have enabled the MPLS on both the interface. That's it. Nothing else is required on R2. Close it. I've enabled OSPF, configure the interface, and enable MPLS. On R3, this is another P. Again, we have same scenario. Then on C router, just IP addresses are configured. So IP interface, brief, exclude, unassign. You can see here, my LAN subnet is 192.168.1.0. So IP address is 1.1 over here. Here, so IP interface, brief, exclude, unassign. Done. Good. IP addresses. Now let me configure first service provider routers. Let's have a BGP session between 1.1.1 and 3.3.3. For iBGP, you know indirect neighborship in iBGP. BGP ES number 500, neighbor 3.3.3.3, and remote ES 500. What other command I need to run here?
So that MPLS was only on need we need on R2 only, right?
No, it is required on R1 as well.
That internal interface is only
Yes,
01 and
yes,
00.
yes.
Oh.
MPLS cloud facing interface only. Yeah. What other command is required over here?
Source loopback,
Yeah, very
Next
good.
hop.
neighbor, then and source loopback
Neighbor
1.
3.3.3, update source loopback 1. Then go to R3, config the router BGP 500 and neighbor 1.1.1, update source loopback 1. You will be also running, what happened? Neighbor 1.1.1, update source.
Neighbor command. We need to define neighbor
Neighbor
and remote ES.
remote ES 500 and then neighbor 1.1.1, update source loopback 1. You will also run update next hop IP address, next hop self, but I will do that later, no worry. Now service provider is going to add one more neighbor command for customer, right? Service provider engineer is going to ask to customer, bro, what ES number are you using? And customer will be using private ES number. customer will be using private. We have two types of ES, two type of public IP address, private, public. We have two types of port number, private, public. Similarly, we have two types of ESN. We have two types of ESN, autonomous system number, private and public. Service provider will be using public ES number because now service provider is also going to advertise some prefixes too. Other service provider internet, right? This service provider can not only give you the connectivity, can also give you the internet access. If you want, you can ask for internet access to your service provider. It will start advertising one default route, and on the customer router you can limit the internet access. Okay, those are another things. We'll do that later. Now for provide customer, what is the neighbor IP address? 14.1.1.4, and remote AS of the customer is 100. 14.1.1.4 and remote AS of neighbor is, what it's saying, can't configure the local system as neighbor. Do so IP interface brief exclude.
14.1.1.1.
IP is incorrect over here. Interface D0/0. IP address is going to be 14.1.1 here. 255.255.255.0. And now router BGP 500 and neighbor 14.1.4 and remote AS of neighbor is 100. That's it. On R3, router BGP 500 and neighbor 35.1.5 and remote AS is 100. That's it. Now let's configure the customer router. R4 config T, router BGP 100 and neighbor 14.1.1, remote AS 500. Then R5, another side of C, router BGP 100 and neighbor 35.1.3, remote AS 500. Now I'm expecting neighborship between router 4 and service provider router P, between C and P. Here you can see. So IP BGP summary. Good. No any prefix is coming from the neighbor. On R5, so IP BGP summary. Good. And on service provider router, so IP BGP summary. Two neighbors are there, 3.3.3 and 14.4. 14.4 is customer, 13.3 is my remote PE. Remote PE. Right? No any route is coming from any neighbor. Now let's advertise one prefix from side 1 of customer A. Router BGP 100 and network 192.168.1.0 mask 255.255.255.0. So IP BGP. Good guys. It is self-advertised route. Some attributes. Forget about the attributes. Next hop 0.0.0 self-advertised route. Prefix is valid as well as best. Now R4 will advertise it to their neighbor. So IP BGP neighbor, who is neighbor 14.1. So let me take you to R1 provider edge router. So IP BGP. Here you can see in the BGP table 192.160.1.0 next hop IP address is 14.4. Now R1 is going to advertise it to another neighbor. So IP BGP summary. Here you can see it is learning one prefix from this neighbor. Definitely it will advertise to this neighbor. But on R3, so IP BGP route is valid but not best. If it is not best, then R3 is not going to use it. Use it means what? It will not install in routing table. It will not advertise to the neighbor. Tell me why.
Next hop is not reachable.
Not reachable to next one.
Yeah, because this next hop IP address which is coming with this prefix in the update message is not reachable. Even if I'm going to have a static route for this IP address, that will not work because router 2 don't have route then, right? But R1 is my border router. Here I can run what? Next hop self command. Right? So go to R1 and say, bro, whenever you will advertise route to remote P 500, remote P 3.3.3, then next hop self set your own next hop IP address, and next hop is not going to be exit interface because we are already running update source loopback 1. Enter. Now go to R3, clear your BGP table once, clear IP BGP star soft in, and then show IP BGP, and now you can see next hop is coming what?
1.1.1.
Good. That's why now prefix is valid as well as best. R3 is going to install it in routing table, and now R3 will advertise it to another neighbor. So IP BGP summary, it is learning from this neighbor 1.1.1, it will advertise to 35.1.5. so go to R4 and check. So IP BGP, sorry, R5, so IP BGP. Oops, route is not present in the BGP table of R5. Let me see, R3 is advertising it to R5 or not. Go to R3, so IP BGP, so IP BGP and neighbor 35.1.5, and show me the advertised route. Are you advertising any route? Yes, I am advertising this route with next hop port 1.1.1. I'm advertising. See, this is my command. So IP BGP neighbor IP address advertise route. Okay, so R3 is advertising to R5, but R5 don't have route in BGP table. Let me see. So IP BGP neighbor 35.1.3. Are you receiving any route? Tell me receive route. Show me receive route. Okay, let me add one command here. Router BGP 100 and inbound, sorry, neighbor 35.1.3 and inbound soft. What is the command? Reconfiguration. Disable connected check rule, EBGP multi-hop, failover, filter list. No, BGP peer group. Then soft reconfiguration, and for inbound. Anything else? No. And now you can use this command. So IP BGP neighbor receive route. You can see receive route is showing what? 0. So we have verified one thing here, that R3 is advertising it to R5, but R5 is not.
Receive.
Yes, receive. Why it is not receiving? Anyone? This is what we have.
EBGP AS rule.
eBGP loop avoidance rule. When R4 will advertise the subnet 192.168.1.0 to R4, it will also advertise ES path 100. When R3 will advertise to R1, it is not going to include ES number, only 100 is there because it is advertising to their iBGP neighbor. When R3 will advertise to R5, it is going to add their ES number. Means now destination is to ES, a bay, and R5 will find their own ES number in the update message. It will discard. So let me tell to R5 to allow ES in. Go to R5, config T, router BGP 100 and neighbor 35.1.1.3, allow ES. Allow ES in. That's it. Allow ES in. And then show IP BGP. So IP BGP receive route. Now you can see it is receiving this route from this neighbor, and next hop IP address, right? R3 is advertising to their eBGP neighbor, so it will change the next hop IP address, and so IP BGP. Now you can see BGP table and so IP route BGP. It has installed the route in routing table, right? This route is coming from side 1. In side 2 C router, you can see Good. Now here I am going to advertise another network, router BGP 100 and network 192.168.2.0 and mask 255.255.255.0. So IP BGP. Good. It will advertise to R4. So IP BGP. Sorry, not R4, R3. So IP BGP. Okay, both the routes are there. Next up, IP address 35.5 exit interface of R5. It will advertise to R1. Go to R1 and check so IP BGP. Again, we have same issue. This prefix is only valid, not best, because of next hop IP address. So go to R3 and say router BGP 500 and neighbor 1.1.1. Next hop self. Next hop self, and then go to R1 clear IP BGP star soft in once and so IP BGP. Now prefix is valid as well as best because next hop is reachable. Now R1 will advertise to R4. So on R4, so IP BGP, it's not present in BGP table. What I need to do, I need to allow my router BGP 100 neighbor 14.1.1 allow yes in and so IP BGP. So run section BGP. Good na? Clear IP BGP star soft in so IP BGP. Okay. And this route will be also installed in routing table. So IP route BGP. Now route is present. Now we have connectivity. Done. Now side 1 and side 2 can talk to each other through service provider network. If you will ping, ping is going to work. Ping 192.168.2.1 and source 192.168.1.1. What happened? Let's verify the packet flow. If I am going to ping from here, what will be the source IP address? Source IP 192.168.1.1. Destination IP 192.168.2.1. Whenever you have connectivity issue, you should verify the packet flow. Right, user will send traffic to R4. R4 is going to compare destination with routing table. So IP route 192.168.2.1. Route is present and next hop is 14.1. It will send traffic from which interface? From 0/1 to R1. R1 is going to compare destination with again routing table. So IP route 192.168.2.1 and next hop is 3.3.3. It will send traffic to 3.3.3. For 3.3.3 exit interface is going to be 0/1. Okay, if it will send traffic to R2, then you know R2 will drop the packet because R2 don't have route. So I don't want in MPLS cloud to forward traffic based on destination IP address. That's the issue. I need to enable what? I need to enable MPLS. Go to R1, then interface G0/1 and MPLS IP. And on R3, interface G0/0 MPLS IP. That's all. So now LDP session will come up here also. Good. And now if you will ping, then ping is working. You can see. Okay. Later, I will again come on this scenario, but for now, there is nothing to learn. Here we have understood few more rules for eBGP, which we need to disable. Clear, guys? Anyone have any question?
In R3, why we gave that soft inbound configuration?
To see the route, what route R5 is receiving from the neighbor.
Okay, no, like only in R3 we configured it. So why we did that? What was the issue before?
No, there was no any issue, and it doesn't solve any issue. See, on
Okay.
R5 still, if I will run command so IP BGP neighbor 14.1.1.1 and receive route, it is not going to show me because what it's saying. Sorry, on R4. See what it's saying. Inbound shop reconfiguration not enabled on this router. That's why you are not able to see what prefixes are coming from this neighbor. So that's why I've enabled it over here on R5. It is not solving any problem.
Okay.
Okay, can I turn off this lamp now?
Regarding MPLS, like we will learn in deep later.
Yes.
Okay.
Can I move? Say yes if it's clear.
It's clear.
Yes, sir.
Okay, now I'm going to close this lab for now. Shut down. Close. Which lab is this? It is P2P. Name of my lab is P2. This one. Okay, later we will use it again. For now, I'm going to discuss another concept now. Understand? See, in OSPF also we have configured this lab R1, R2. Inside the campus, I have 4 buildings. At each building, I have 1 router. All the routers are connected like this. We have 2 more router here, let's say. Service provider or my company router only. Routers are connected like this, this, R1, R2, R3, R4, R5, R6. Okay, let's say on all the router I have loop back on router number 1, 1.1.1, on router number 2, 2.2.2, because between 2 routers I have multiple path. So if I am going to configure BGP, I should configure with loopback only. So if any router, any link goes down, still you will have neighborship. And here 4.4.4, and let's suppose R5 is learning some route from my remote side, or it is connected to R5 50.1.1.0/24, 50.1.2.0/24, 50.1.3.0/24 coming from data center. It is my service provider like P router, 60.1.0/24, 60.1.2.0/24, 60.1.3.0/24. Right? For reachability between loopback, I'm running here protocol, let's say OSPF. My internal routing protocol is OSPF for reachability between all these loopbacks. Behind router number 1 also have some subnet getting same topology. We have multiple path between 10 and 50 as well as 60. Right, manipulation in these kinds of scenario is important. That's matter for you. But before manipulation and anything else, on router number 1, I need to configure full mesh IBGP neighborship. Like router 1 should have neighborship with R3, R4 and R2. Tell me how many commands I need to run on router number 1. Router BGP 100. After that neighbor 2.2.2.2 remote AS 100. then neighbor 2.2.2.2 update source, loopback 1, right? If you have authentication, then authentication also neighbor 2.2.2.2 password Cisco @123, right? If you have any policy like route map, the neighbor 2.2.2 route map ABC, whatever, and we need to run these command with neighbor to for multiple neighbors for R2 as well as for R3 as well as for R4, correct? If I need to configure neighborship between R1 and R5, then with R5 also, with R6 also, means lots of neighbor command are required on all the router, not only on R1, correct?
Yes, sir.
Right now, okay. One more thing. Let's say here we have a BGP session, and between router 2 and router 3 also have a BGP session. Like if I'm going to configure full mesh IBGP here, full mesh IBGP, then R2 will have how many paths to reach in 10 subnet? R2 will how many paths to reach 10 subnet by default? Just have configured the neighborship on all the router. One directly between R1 and R2 we have link, one via router number 3, one via router number 4. But will R2 receive 10 subnet via router 3 and router 4 by default? No, because of loop avoidance mechanism, right? Here we have to configure what route reflector. Again here for this on router number 3 we need to run neighbor, and then this IP and neighbor IP address, then route reflector clients. So same command on router number 3 as well as on router number 4. Same command on router 1 and router number 2. If we have 6 neighbor, then R1 need to run this group of command, set of command 6 times. To avoid this, we have a concept in BGP called, what do we call it? Anyone? BGP neighbor peer group. What do we call it? BGP neighbor peer group. What you can do, you can create a peer group on a router. Inside that peer group, you can call your all commands, you can run all the commands, and directly you can apply that peer group for all the neighbors. If you want to apply all the commands on R3, you don't need to run all neighbor commands. Just call that peer group with neighbor 3.3.3. You just need to run one neighbor command. BGP. First of all, let's verify the existing configuration. I'm expecting IP configuration and OSP routing protocol. Yes, configuration is there. You can see the host name. OSP of neighborship is coming up, right? This is my full mesh IBGP, and here we have BGP. Okay, good. So IP protocol summary, right? BGP is not running, OSPF is running. So IP OSPF neighbor, right? We have neighborship with router 4 and router 3. Why we don't have neighborship with router 2? So IP OSPF interface brief. So OSPF is enabled on all the interfaces. Check on 0/1 interface. IP address is 12.2. Oh, IP should be 12.1 here. Interface G 0/1. IP address 12.1.255.255.255.0. Save it. So IP OSPF neighbor. Now 3 neighbors are there. R2. So IP OSPF neighbor. Good. And so IP route OSPF. You can see through OSPF routing protocol, we are not receiving these 10 subnets. Only loopbacks are reachable, and some inter-router subnets are there. That's it. Now on R3 also enable so IP route OSPF or so IP OSPF neighbor. You can see 3 neighbor, router 2, router 4 and router 1. And on router number 4 also I am expecting same. So IP OSPF neighbor, 3 neighbor. Now I need to configure IBGP full mesh neighborship here. See, instead of running lots of neighbor command with all the neighbor, what I will do, I will go to router BGP 100 and I will create a peer group. Neighbor and name of my peer group is, let's say, IBGP peer. Name of my peer group. And here I'm going to say peer group. And now run whatever command you want to run with all the neighbor, like update source loopback 1. This command is for all the neighbors. So neighbor and call your peer group neighbor, this neighbor and update source. Before that remote ES. What will be the remote remote ES 100. The neighbor IBGP peer, which is name of my peer group, then update source loopback 1 neighbor IBGP peer group password Cisco 123. And now I am going to apply these all commands with all the neighbor 2.2.2.2 neighbor 2.2.2 peer group and name of your peer group IBGP peer. That's it. All the commands will be applied with this neighbor. Then similarly neighbor 3.3.3 neighbor 4.4.4. So we have run all the commands with this neighbor 4.4.4, like neighbor 4.4.4 remote ES 100 neighbor 4.4.4.
Sir.
Hmm?
No, okay.
Update source loopback 1 neighbor 2.2.2 password Cisco 123 neighbor 2.2.2 whatever on all the router. Now go to router number 2. On router number 2 also I will do same thing. So what I can do here, either I can run the command manually router BGP 100 neighbor IBGP peer group, and after that neighbor my peer group update source loopback 1, right? Neighbor IBGP peer group remote ES 100 and neighbor IBGP peer group password Cisco at the rate 1, 2, 3. And then I will apply it for neighbor 1.1.1 peer group IBGP, neighbor 2.2.2 peer group IBGP. Now you can see neighborship with 1.1.1 and 2.2.2 is up. Sorry, this is my local IP address 3.3.3 and neighbor 4.4.4. Then go to R3 config T router BGP 100. Right now I'm only 4 neighbors. If you have 10 neighbors, it can simplify lots of configuration. Neighbor, then peer group name and peer group, neighbor, peer group and remote AS 100, neighbor, peer group and update source loopback 1, neighbor, peer group, then password Cisco at the rate 123 and apply this neighbor 1.1.1.1 peer group, this one, neighbor 2.2.2 neighbor 3.3.3, no 4.4.4. Similarly on router number 4 also, router BGP 100 neighbor IBGP peer group, neighbor IBGP peer group remote AS 100, peer group IBGP update source loopback 1, neighbor IBGP peer group and password Cisco at the rate 123, and then neighbor 1.1.1 peer group, neighbor 2.2.2 peer group, name of my peer group, and then neighbor 3.3.3 peer group name.
Is Cisco at 123 the C is capital or small?
Small. That's why we have neighborship now.
Okay.
Now you can see neighborship is UPSO IP BGP summary. Done. Has 3 BGP neighborship on router number 2. So IP BGP summary on router number 3. So IP BGP summary on router number 4 also. So IP BGP summary. So just it is used to simplify the neighbor commands, nothing else. Correct, guys? We have replicated the commands inside the peer group to all the neighbors. And we have now full mesh IBGP. If R2 will goes down, okay, forget about the R2 goes down. Now let's do one thing. Let's advertise these prefixes on router number 1. So IP interface brief exclude unassigned. So these loopbacks are already there. These loopbacks. So I have two ways to advertise prefixes in BGP here. I can say redistribute connected also. I can say redistribute connected, but if I will say redistribute connected, it is also going to advertise the network which is running on loopback 1. So if I have selected loopback interfaces and I want to advertise that in BGP, I can use route map. I can use route map because through network command you all know how to advertise prefixes. Now let me show you the another way to advertise prefixes in BGP. Okay. So route map, let's say name of my route map is permit 10, and here I am going to match interface loopback. What loopback you want to match? Loopback 1, then loopback 2, then loopback, sorry, not 1, 2. What was the loopback where 10 submit was running? Loop back 10, 11 and 12. Loop back 10, loop back 11 and loop back 12. And now go to router BGP 100 and say redistribute connected and use route map, because I don't want to advertise all connected prefix. If I'm going to hit enter over here, it is going to advertise all connected routes in BGP. So let me apply route map. Name of my route map is advertise network. That's it. If you want to define the metric, you can also define metric over here. And now show IP BGP. So this is also one way to advertise networks in BGP. Are you guys able to see any difference over here when I am advertising prefix with the help of redistribution and when we are advertising routes with the help of network command? There is one difference.
Under the path, it
Yeah,
shows
under the path, here you can see this is called incomplete. This is origin code in BGP. One attribute. Now on router number 2, show IP BGP. In BGP table, here we have only one path. Router 2 should receive this from 3 neighbor, na? So IP BGP summary. 3 neighbors are there. But why it is receiving from only one neighbor? Why?
IPGP, that rule
Loop
loop avoidance.
avoidance mechanism. So now I need to tell to router number 3. Router 3, your all neighbors are route reflector client. What I can do? I already have the peer group, so run section BGP. So this is my peer group name. I'm going to add the command inside this peer group only. Router BGP 100 and neighbor this one and route reflector client. And now on R2, so IP BGP. Now how many paths are there? How many paths are there, guys? 2 paths are there. If I am going to add this command on router number 4 also, router 4 config t do so run section BGP, peer group name is IBGP peer, router BGP 100 and neighbor this one and route reflector client. Then on router number 2 I am expecting how many paths this time? 3 paths. You can see for all 10 subnets, how many paths are there? 3 paths. Now let's come on the most important part of BGP, best path selection. There are 3 paths available for this subnet 10.1.2.0/24. Next hop IP address in all the path is one only because all the prefixes are coming from IBGP neighbor and IBGP neighbor doesn't update next hop IP address. Yes or no? If I want router 2 should advertise the prefix with next hop 3.3.3, what can I do?
Next hop self.
Next hop self command will not work, sir.
Route map. Next hop self all.
Next hop self command only works on border router. Many times I have told you this.
Yeah, sir, but actually I did a lab in that I did a next hop self all. So that also worked with the IBGP.
What is next hop self all?
Just the same command, just I give the all keyword after that. So it kind of break the like this exception.
Okay, good. Congratulations. Okay, so till now we have not talked about next hop self all lib. What is the another way?
Route map.
Route map, policy.
Route map. Okay, right now here, can anyone tell me which path is best path by looking into the BGP table? Which path is the best path?
which is valid and also best.
Hmm? By looking into the BGP table like this, we can note, say which path is the best path, because next of IP address, see, everything looks same. So now I'm going to open any prefix in detail in BGP table, and I want you to understand the path in BGP. What? Path in BGP. How to check path? Let me open it. So IP BGP 10.1.1.0. Are you guys able to see three path? Path number 1, path number 2, and path number 3.
Yes.
All the paths are valid, but only one path is best. Which path is best? Who will tell me?
The last one dot.
The last one is the best. The last one, this one is the best. And see, in all the path, see, first of all, whenever you will check BGP path, and the path which is coming from route reflector will have one more information that is called cluster list. Cluster list is nothing but router ID of your route reflector. Two more attributes will be added by your route reflector. One is originator, and the another one is cluster list. This originator is nothing but the router ID of a router who is originating that prefix. So what is the BGP router ID on router number 1? 10.1.3.1, highest loopback IP address, correct? On router 1, so IP protocol. Can I view the router ID, BGP router ID? So IP BGP neighbor, here also you can neighbor router ID and self router ID. This is BGP neighbor is 2.2.2 neighbor IP address. This is not the router ID. Router ID of router 2 is 20.1.3.1 and local router ID is 10.1.3.1. How can I change the router ID on router number 1 for better output on R2? What is the command? BGP router ID 1.1.1. On R2, router BGP 100 and BGP router ID 2.2.2. R3 BGP router ID 3.3.3, and on R4 BGP router ID 4.4.4. Go to R2 and now clear IP BGP star soft in to send a route refresh message, and so IP BGP. What happened? Nothing is there in BGP table. Route is not coming from the neighbor. What happened? Nothing. R1. R1 is advertising these prefixes. R1 is advertising these prefixes to R2 as well. Now see, okay, it was just taking some time. Now let me open the prefix 10.1.1.0. Now three paths are there. Now you can see the originator ID. Originator ID in all the path is 1.
Same.
It means originator is same. And are you able to see originator information and cluster list information in this path? in this path?
No.
No. It means this path is not coming from route reflector, right? This is not reflected path, and these two are reflected path. If you have originator information and cluster list information in any path, it means it is coming from route reflector. It means this is reflected path. Clear, guys? So these two paths are coming from my route reflector, and this path is coming from my neighbor, direct neighbor. Which type of neighbor? Internal neighbor. All are internal neighbor. Can anyone tell me on the basis of which attribute how router 2 is selecting best path? How this path is the best path? Or if I am going to set the neighborship between R1 and R2, if I will set the neighborship between R1 and R2, then router 2 is receiving 10 subnet from route reflector only. It will receive route from route reflector. So this path and this path will be there.
Sorry, can you repeat, sir, once again?
Or if I will set the neighborship between R1 and R2, then we will have only these two paths, route reflector path.
Okay.
Okay. And how we can identify these two paths are coming from route reflector? Because of cluster list. Cluster list is nothing but the router ID of my route reflector. Originator is nothing but router ID of router who is originating that prefix. And out of these three paths, this path is best path. By default, BGP doesn't support. By default, BGP doesn't support what?
Load balancing.
Load balancing. Maximum path is
1.
1. And here are your attributes used for best path selection. First attribute is next hop. Check in all the path next hop IP addresses are reachable or not. Next hop. Next hop. This is what? This is next hop. So next hop IP address is reachable from all the path. Then it is going to check second attribute. This attribute tie. Second attribute is weight attribute. See the weight attribute. Is weight there? No. Right? BGP doesn't advertise weight. For self-advertised route, weight attribute is 32768. For self-advertised prefix. For received route, weight attribute is 0, and this is Cisco proprietary attribute. You will only encounter weight attribute on Cisco devices, not on other vendor devices. So leave weight attribute is not there. The next attribute is local preference. What is local preference value? 100, 100, and 100. Oh, so based on this attribute also router cannot select best path. Then it is going to check next attribute, which is self-advertise. So these are all the paths are coming from the neighbor, not self-advertise prefix. So this attribute will not work here. Next attribute is ES path. See, the ES path means ES number. How many ES number are there? So all the paths are coming from IBGP. Like, see, in this domain we have only IBGP, BGP 100. So no one is going to see our ES path information, correct? When router advertise prefix to their IBGP neighbor, it doesn't include ES path. That's why we are not able to see any ES path over here. Next attribute is origin code. Origin code in all the path is same, tie. So origin, this attribute also tie. Next attribute is mid. Mid is metric. Metric is same the metric. Metric is also same 0. Okay. Next attribute external over internal, all are internal. The next is IGP cost to reach. Next hop. IGP cost to reach next hop. Next hop is same 1.1.1 only. IGP cost to reach next hop is same. If I am going to update next hop on R3, R4, like here on R3, if I am going to create a route map, route map next hop permit 10 and set IP next hop 3.3.3. Set IP next hop 3.3.3 local IP address and a router BGP 100 neighbor. What was the peer group name? I will attach all the command with peer group only. Peer group name, this one. So neighbor, this one, and use route map. What is the name of my route map? Next hop. Direction will be what, guys? In or out? Direction out. When R3 will advertise. Now let me take you to R2. Clear IP BGP star soft in and so IP BGP 10.1.1.0. Now you can see when the cluster list is 3.3.3, then next hop IP address is what? 3.3.3. And when the cluster list is 4.4.4, then next hop is still. This is what we have learned, right? To update the next hop IP address, correct? Here also I'm going to create a route map with name next hop permit 10 set IP next hop 4.4.4.4 exit router BGP 100 and do so run section BGP neighbor peer group this one and use route map next hop next HO direction out and go to R2 clear IP BGP start soft in and show IP BGP 10.1.1.0. Now you can see from all these three paths next hop is unique, correct? So if cost to reach this next hop is lower than this next hop and this next hop, then this path will be preferred based on this attribute. Based on this attribute, this is the last attribute used for best path selection in BGP. IGP cost to reach next hop. But right now, you can see we have three paths and IGP cost so IP route 4.4.4.4. IGP cost to reach this next hop is 2, 3.3.3. IGP cost to reach this next hop is also 2 and 1.1.1. IGP cost to reach this next hop is also 2. So this attribute also tie. This attribute also tie. Whenever you want to perform load balancing in BGP, then attributes till IGP cost to reach next hop should be same. Should be same. Then only you can achieve what load balancing. Here, if I am going to say maximum path 2, might be possible my router is going to perform what? Load balancing, right? Config T, router BGP 100 and maximum path 2 and enter and clear IP BGP star soft in and then show IP BGP is it performing load balancing?
Yes.
Yes. So IP route BGP is it performing load balancing? 1 minute guys, just
No.
coming. 1 minute please wait. 1 minute. Till then think of it. You guys can talk to each other. See why load balancing is not happening.
Hey guys, any of you meet up to go over the work or to study or anything?
Sorry, Dwight, can you repeat?
No, I was asking I mean we're in the group, I never heard if anyone said that they meet up if any other participant like to go over the scenarios or to study or anything. Do you guys do that?
No, no, yeah, but yeah, we can do that like anytime if you want to discuss or something. Yeah,
Yeah, that's what I was thinking. Maybe from time to time you could probably meet up like when we do have class or something.
yeah, sure, yeah, that
Maybe
would
on
be,
the
but
week,
especially now, if
maybe on the
yeah,
weekend.
yeah, sure, sure.
Because
Especially
I
now.
realize, yeah,
Mhm.
it's getting a little bit intense, you know?
Correct, correct, yeah.
Yeah, so I don't know. It's just a suggestion. I mean, it's up to you guys. Especially for the labs. Maybe it would be a good idea if all of us on the same page when it comes to the labs.
Yeah, we can do that.
Okay, great.
Yeah. Yes. Anyone? So IP dot BGP 10.1.1.0.
There was a lowest, I think, in that list, lowest router ID,
No, no,
lowest neighbor
that
router.
is okay, but I have configured maximum path 2. It should perform load balancing, na? That is tiebreaker. Lowest router ID, oldest path, lowest neighbor IP address. Those are what? Tiebreaker. Definitely my router should not select best path based on lowest IP address. Yes or no? Those are tiebreaker. Otherwise, if my router is selecting best path on the basis of lower neighbor IP address or based on lower router ID, neighbor router ID, then you are not controlling it, right? BGP is controlling which path will be the best. According to BGP, maybe ISP1 is the best, but in reality, you have better path through ISP2. Those are tiebreaker attribute because maximum path is configured as 1. Right now, my concern is why load balancing is not happening. Router BGP 100. Here I have configured maximum path 2. So now I am going to say maximum path 2. That was maximum path 2 for eBGP. For iBGP, maximum path 2. And then clear IP BGP star soft in and then show IP BGP. And now you can see it is selecting
Two paths.
2 paths. Now load balancing is happening. If I will configure 3 path, it is going to install all in routing table router BGP 100 and maximum path 3. Now so IP BGP all the path are best. Now so IP route BGP, you can see all these 3 paths are installed in routing table. So if you want load balancing, BGP should perform load balancing, then all the attributes till IGP cost to reach next hop should be same, then only you can achieve load balancing. If BGP is selecting best path till 9th attribute, then you cannot achieve load balancing. Now here I am going to again configure router BGP 100 and say no to this, and maximum path 1, clear IP BGP starts opt-in.
Okay, sir. So till 9, so if the IGP cost is same, then only load balancing will happen, right?
Correct. Now you can see maximum path is configured as 1. Now it cannot perform load balancing. Now question is how BGP is going to select best path then? That's why we have some tiebreaker attribute. 10th number attribute is oldest path. 11th number attribute is lower neighbor router ID. And last one is lower neighbor IP address, because sometimes it might be possible that my router has connectivity like this.
Yeah, dual link.
R1, R2, right? And here we have a subnet, X subnet, R2 is advertising. So in both the path, neighbor router ID is going to be 2.2.2 only. Then how router 1 is going to select best path? In that case, it will check lower neighbor IP address. And this is the tiebreaker for eBGP. For eBGP, like if a router is receiving two path X, and here we have eBGP neighbor, right? And IGP cost to reach next hop is same from both the path, from both the neighbor. Then it is going to select one path based on oldest path, as we have eBGP neighborship, as it is receiving path from eBGP. If one is eBGP, one is IBGP, then best path selection can happen over here at 9th attribute, correct? If both are eBGP, then best on oldest path. If router is going to receive path from this router first, that will be installed in routing table. Oldest friend is always best friend.
Oh, okay, sir. So if both are IBGP, then this rule number 10 won't be used.
Correct. Right. So in my case, this rule is not working oldest path. Either router 2 is selecting best path based on lower neighbor router ID or based on, lower neighbor router ID or based on lower neighbor IP address. Now you tell me based on which attribute router 2 is selecting best path. All the paths are in front of you. Yes, this path is the best path. This is neighbor router ID. So here based on lower neighbor router ID, R2 can select best path, right? Based on lower neighbor IP address, it is selecting what? Best path. I want router 2 to select best path via either R3 or R4. What I can do, I can increase the IGP cost to reach next hop 1.1.1. Right, like here on router number 2, if I will go to interface G0/0, how it is calculating IGP cost to reach next hop? Through OSPF routing protocol, IP OSPF cost 10. And now show IP BGP 10.1.1. Best path. Which path is best path? Still this one. IGP cost to reach 1.1.1 is what now? So IP route 1.1.1. And IGP cost to reach 2.2.2. Sorry, 3.3.3. Based on IGP cost to reach next hop, which path should be best? Either R3 or R4. Which path is best now? Which path is best?
Sir, can you show how you change the cost once again?
IPOSP up cost.
On the interface, right? Towards that. Okay, thank you.
Okay, now IGP cost to reach, so IP BGP 10.1.0, right? Three paths are there. IGP cost to reach this next hop is 3. IGP cost to reach this next hop is 2. This next hop is 2. Now router need to select best path out of these two paths. Again, IGP cost to reach next hop in both the path is same. Router will move to next attribute. For both the neighbor are IBGP neighbor, it is not going to check oldest path. It will check lower neighbor router ID. And here you can see neighbor router ID is 3.3.3. Here neighbor router ID is 4.4.4. So lower neighbor router ID is best. If I am going to change router ID on router number 3, router BGP 100 and BGP router ID 30.1.1, and so IP BGP 10.1.0. Now you can see best is via router number 4, right? Path is not discovered yet via router number 3. Soon it will discover. It can take some time. आजा भाई कहाँ खो गया come on babes done best is how this path is the best path. IGP cost to reach neighbor next hop IP address is 2. IGP cost to reach next hop is same. IGP cost to reach this next hop is 3. Neighbor router ID is 30.1. Neighbor router ID is 4.4.4. But best is still via router number 3. Is there any another attribute through which best path selection is happening?
Oldest path.
No, oldest path for eBGP. This is not what I am expecting. Oldest path is for eBGP. If I'm not wrong. Cluster list 30.1, cluster list 4.4.4. Reselecting, I think, best path based on lower neighbor IP address. Based on lower neighbor IP address. Router BGP 100. Mm, 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 mm. Am I missing something? BGP best path. Okay, IBGP matrix and matrix in the best path selection. What this command will do? This will ignore IGP cost. So if I will ignore IGP cost, then link between R1 and R2 will become best path compare router ID. Okay, this is the command. I was missing this command. Okay, so by default this command is removed here. That's why. Now clear IP BGP star soft in, and so IP BGP 10.1.0. Still best path is R3. Config T router BGP heart rate, BGP best path, compare router ID, compare router ID for identical eBGP path. Okay, this is for eBGP. Ignore metric, ignore metric. If both path doesn't have iBGP, ignore on the path comparison. Mm, 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 mm. Compare router ID is fine. Compare router ID is for eBGP. For eBGP also we can compare. See, at least you have learned one thing over here. By default, for eBGP, router is only going to check what? Oldest path. But if you want, you can also say it. Compare router ID for eBGP. For iBGP, I am missing command. Both path doesn't have iBGP. No path comparison. Mm, 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 mm.
Sir, I was just checking online, so, so somewhere it is written that if it is reflected route,
Mhm.
it will compare the originator ID.
It will compare the original ID is same. After that,
Yeah, yeah, and after that it will check if it is direct route or reflected, and it will choose the direct path.
no, direct. It
So
has
if
not selected the direct path. So IP BGP 10.1. It is selecting the reflected path only.
from where R3.
Right, this is the direct path. Right, so maybe that's wrong on Google.
Yes,
It's
so what's happening, say the originator, it will compare the originator ID if they are both reflected, something like that.
originator is same, na? No, don't go on in Google. Right, Google cannot answer these questions. Right, see, both are reflected path. This is direct path. Direct path is not best. It's only valid. And in both the reflected part, originator is same.
Yeah, so it was saying that originator both are same, and then it will move to the lowest neighbor IP.
So that's what happening. Yes,
Yeah, if we remove reflect, like because the originator ID is same for both, it is deciding taking lowest neighbor IP as a tiebreaker.
yeah, that's happening. Here, Here can't we use router ID for the best path selection? So IP BGP 10.0.
Sir, can you if you swap there maybe
Now which
uh,
path is best path, guys?
yeah.
Direct path. Because now it is not selecting IGP cost to reach. Next up we have ignore the metric. This is working fine. No, bro, I will not go with Google. Google cannot answer to these questions. Google will just make you confused. When I have dot, I cannot find the answer on Google. I can hardly use Google like Cisco community. I can post there. Have, right, most probably I will get the answer from some working professional. But if you will search these things on Google, hardly sometime you can find the correct answer. Right, because anyone can post on the Google, na? I can also post on my website, and if someone will search, if
No,
not,
not on. Yeah, he was just asking Chat GPT the scenario. So it said it will work that if we do not have any route reflect, then it is fine. But as soon as that route reflector comes in,
yeah,
it
then we
will
know, na.
ignore.
Then we know here
Yeah,
are the sequence. Then we already know this is the best path
correct.
selection. When routes are coming from route reflector, then router is selecting best path based on lower neighbor IP address, right? If the originator ID is same. If
Correct. Yeah, it was. Yes.
if originator ID is not same, then it is going to prefer lower originator ID. That is also the concept. It's like selecting best path between multiple route reflector. Okay, so no worry like whether it is selecting best path on the basis of lower router ID or based on lower neighbor IP address in case of IBGP. Both are tiebreaker attribute. Oldest path first, oldest path, lower neighbor router ID and lower neighbor IP address. All are tiebreaker attribute. And if I want load balancing, then attributes still here should be same. Right now, if I have my best path is direct link because I have ignored the matrix. First of all, I'm going to remove that command. No IP BGP 100 and say no IBGP matrix ignore and so IP BGP clear. Sorry, IP 10.1.0. Best path is now again via R3. Right, so it's not selecting best path based on lower router neighbor router ID. I'm going to remove the router ID command as well. I'm going to say default router ID BGP router ID 3.3.3.
Can that originator router ID be changed or manipulated somehow like route map or something?
Like you can advertise the prefix from here R3 itself. You can have,
Okay, same prefix. Okay, okay.
yeah,
Then we can check. Okay, yeah.
definitely you can check. So this is my BGP best path selection. Clear to all? Any question? Anybody? In BGP best path selection. Now we need to understand these all attributes one by
Sir, any
one.
shortcut to remember these?
Practice, right? Practice, wait First of all, next hop, then wait, local preference. Self-advertise, you don't need to remember, you know, in your all IGP protocol also what happened. Self-advertise routes will be for our received route. So just keep in mind, wait is before local preference. Right, attribute is starting from next hop, then wait, even wait is not used for best path selection, it's only used for manipulation. BGP doesn't carry wait attribute in their update message. So my one attribute is over here, that is local preference. Then we have ES path. After that, matrix, external over internal, IGP cost to reach next hop. Only 3 to 4 attributes are there, which will be used. Correct. For the manipulation also, we will be using local preference, ES path, and mat. Only these 3 attributes. In production, you will discover or encounter local preference, ES path, and mat for manipulation. Right? Origin code is good, but most of the time you are going to advertise prefixes with the help of network command, so origin code is going to be same. Like in origin code, you need to remember that network command routes will be always be for our redistributed route. In ES path, route with lower ES path will be always prefer, right? If a router is receiving a prefix, a router has two path for 10.1.1.0/24, right? From one path, there are 3 AS number in between, 10, 20, and 30. From the another path, only 2 AS is there, right? So it means what? Destination through this path is closer. Only 2 ASA are there in between. So it will prefer lower ASA path. So no need to remember, just you need to practice, you will understand. When will perform the manipulation, you will understand, and no need to remember this in this sequence only, because you will have idea at the end that either I can manipulate the weight, local preference, ES path, or metric. But attribute is one of the most important concept of BGP. If you understand the attributes, then only you can perform manipulation. You know, BGP is an internet protocol. We are going to perform lots of manipulation, right? And that's done using these attributes. So tomorrow we'll start the attribute. Till then you can practice whatever we have discussed today. First we discuss how to connect two sides of a customer through service provider network. You need to run allow ES in, you need to run next hop self command, and next hop self command all, next hop self all is used to set next hop forcefully on the router. Forcefully you are going to tell to router to set your next hop. Okay, you can do that on any router. Forcefully we can set next hop IP address on any router. But what I had told you, that you will create policy to apply the next hop, because it is not mandatory that every time my next hop is going to be exit interface IP address. See, when R3 is advertising this 10 submit to R2, next hop is not exit interface IP address. What is next hop? Look back, 3.3.3.3, right? So when you will apply the route map, you can set any IP address as next hop, and even that is also possible that R3 is advertising the route, but while forwarding traffic I want to follow this path. So I can also tell to R3, bro, advertise these prefixes to R2 and set next hop of R4, this interface IP address. That is only possible when you will use route map. Not forcefully we are going to say our router to set the next hop IP address. Okay. Now this is all for today. We'll continue from here tomorrow. If anyone have question, please ask. We have some more attributes as well in BGP. right? These are for best path selection. What? Best path selection. For best path selection, we have total 13 attribute. No. Sorry, 12 attribute. Again, no. For best path selection, we don't have 12 attributes. We have 9 attributes. 3 are tiebreaker, right, for load balancing. And how router is going to select best path if all the attributes till IGP cost to reach next hop is same. And we can also manipulate it, right? Like we can change the behavior as well. The how router should select the best path. Like you have seen, I said router, please ignore the checking next hop cost, right, for best path selection. And there was lots of other options as well. So we can change the behavior, best path selection behavior as well on the router. I can say router, please use a router ID for best path selection in eBGP. I can do that. What is this? This is changing the behavior. But by default, behavior is what we have discussed in the sequence. Router will check from attribute 1 to attribute 9th. After that, router don't have any option if multiple paths are there, because maximum path is configured as 1. So either router is going to use oldest path or lower neighbor router ID or lower neighbor IP address. For the manipulation, we have wait, local preference, AS path, and metric. With the help of these attributes, we'll see some real-time scenarios and we'll see the manipulation tomorrow. So tomorrow class is going to be very, very, very important. Right, but before that, guys, before manipulation, whatever rule we have understood, discussed, those are too important. More important than manipulation. Otherwise, you can't understand the manipulation. Okay, so make sure you have practiced all the rules. You have connected two sides of a customer. You have configured the peer group also, and you did the route reflector as well. When you know these things, then you can understand the manipulation very easily. Leave everything on me, right? I'm good in teaching.
You are very good, sir. You just go a little fast. That's all.
Yes, sir, you are going very fast.
But see, we have 6 hours of content on BGP and we are still on best path selection. I am not going fast. I am talking about managing even small things. That's why you feel it's fast.
So BGP is very important topic. That's why.
Yeah, it's very important, but we have only covered 3 to 4 topics now. I go in deep
Yeah.
in every basic topics. That's why you feel it's fast, but it's slow. Trust me. At the
No,
end, now,
I catch up by watching the video again, so it's okay. So don't worry about it, sir. Don't worry about it.
a trainer cannot teach you
Yeah,
everything.
perfect.
Trainer can help you to learn, right? I am preparing you guys to learn, forcing you to learn, right? Sit, watch the recording, configure the lab,
So
and
you're
then
doing a brilliant job, sir. I appreciate it very much.
otherwise sitting for 2 hours in live class is not possible, you know.
No,
Only
sir, it's
10
good. It's
to
good. You're
20%,
very good.
10 to 20% people only complete online courses. Rest lives in between.
Yeah.
If you are
Well, we
sitting
still
for
have,
2
so
hours,
we're still going strong. We still have.
exactly. And see, now when we are done with
Yeah.
OSPF class, now you know all the LSAs, you know the states, you know the types of routers, you know the areas. If you want to revise, definitely you have to sit, you have to configure. As much as you will practice, you will be becoming expert, right? But now you are very good enough to understand anything in OSPF. If you forget something, you can read the book and you can understand. You can read the article on
Definitely,
internet.
sir. Thank you, sir. Thank
So
you
I
very
am
much, sir.
preparing you so that you can learn. I don't expect I will teach everything. That is not possible. No one can teach. Okay, sir. Then see you tomorrow. I'm going to share the
So we
recording.
appreciate you. Thank you very much. Bye bye.
Most welcome. Most welcome. Most welcome. Bye bye. Good night.
Okay, bye bye, sir. Good night.
Yes,
Sir,
Nadeem.
please share the recording.
So in the yesterday class, we have a reachability option 5 total. One is static route, and second is advertising the routes different network, and third one is dynamic routing protocol in like OSPF, BGP.
One was
And
advertising the WAN link in BGP. One was
yes,
running a IGP protocol. One was a static route. And the fourth
yes,
was through route map.
yes, yes. And the last one is loopback.
Loop back. That was only 4 ways are there, and the last one using route map is the best way, and that is the way through which we are doing it in production. Only 4 ways.
Yes, so we are using in the production only the route map.
Route map, correct.
So can interviewer ask about the remaining 3
Yeah,
options?
definitely.
Okay, sir.
Right. So ask this question to yourself: can I advertise WAN link in my routing protocol? Answer is no. Right. When we have multiple paths for same destination network, can I configure static route? Again, answer is no. A static route is good when we have single path and a small network. Can I configure dynamic routing protocol? Again, router will have lots of unnecessary route in routing table. So what is the solution? Route map.
Yes, sir.
Anything else?
No,
Mukesh,
sir.
do you have any question? Okay then guys, see you tomorrow.